Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hello friends, welcome back to the sessions of computer networks. Last session we were discussing about how to calculate the frame size when the efficiency is mentioned as 100 or 50 or 60%, and the parameters which are mentioned there as Tt equal to 20 ms, Tp equal to 40 ms, bandwidth is equal to 10 kilobits per second. He is asking find the frame size, nothing but L value for the following cases. What are the following cases? 50% of L of u, 60% of L of u, 100% of L of u. So in general example, the L of u is 1 by 1 plus 2a or dt by tt plus 2 into tp. Here I am calculating for option A, that is 50% of L of u. Frame size calculation for 50% of L of u. So L of u equation is, as we know, 1 by 1 plus 2a, and L of u is mentioned as a 50%, so 1 by 1 plus 2a is nothing but 1 by 2, 1 by 1 plus 2a. This becomes 2 equal to 1 plus 2a, so 1 equal to 2a. So here a equal to Tp by Tt. Therefore 1 equal to 2 into Tp by Tt. Here Tt is nothing but L by B. So 1 equal to 2 into Tp by L by B. We want this L value. So how to find this L value? This L value we can get as like this: L equal to 2 into Tp into bandwidth. Okay friends, now using this I can find L value in such a way like this. Two into Tp is 40 ms and bandwidth is 10 kilobit per second. Then 2 into 40 into 10 power minus 3 into 10 into 10 power 3 bits per second. So these will be cancelled, and 2 4s are 80 and 10, 800 bits is your L value. Okay friends, this is how you could get option A, frame size calculation for 50% of L of u. Just do it this. Yeah, well friends, now we will see 60% of efficiency frame size calculation. Here, instead of 50%, you have to write 60%. Okay, so 60% case B. So 60% is nothing but 60 by 100 equal to 1 by 1 plus 2a. So it's nothing but we want to find L value. So 60 plus 60 of 2a equal to 100L. Now what is A value? A is equal to Tp by Tt. Tp is mentioned there as 40 ms by 20 ms. Therefore, it's nothing but 4 by 2. It's nothing but 2. So we come to know the A value is a 2. Therefore, 60 plus 60 of 2 into 2 equal to 100L. So 60 plus 60 into 4 equal to 100L. So 60 plus 240 equal to 100L. Then it is 300 equal to 100L, and therefore L equal to 300 by 100. So L equal to 3 now. So this is how to calculate 60% of efficiency. Copy this. Yeah, well friends, now this you can also do using our regular equation. What is our regular equation is L of u tt by tt plus 2 into tp, 60 by 100 equal to tt by tt plus 2 into tp, cross multiply 60 of tt plus 2 into tp equal to 60 tt. Using that, you can also find what is the L value. Okay, and option C. What is option C is 100% of L of u. What is frame size? So this is very simple. Our regular equation only. L of u is equal to, either you use 1 by 1 plus 2a or use tt by tt plus 2 into tp, and efficiency is given as 100%. 100 by 100 is equal to 1 by 1 plus 2a. So this is nothing but 100 of 1 plus 2a equal to 100L, and do it as usually. Okay, this is how you can derive 60% efficiency frame size, 100% frame size, and 50% of efficiency frame sizes. Okay friends, just to copy this. Yeah, well, now we will see. So far we have used a simple expression, that is 1 by 1 plus 2a, when all delays are ignored. But if at all delays are to be considered, then if delays are ignored, we have written a formula or equation in such a way for link efficiency is tt by tt plus 2 into tp. If at all, if delays are considered, then you have to change your equation L of u equal to tt by, this is for tt for data, tt for data plus tp for data plus tt for acknowledgement plus tp for acknowledgement plus queuing delay plus processing delay. This much you have to use. From this, you want to have 50% or 100% or 60% of efficiency, you can apply. Okay. That's it, friends. This is how the delays are being dealt with the physical layer. Okay. Now we will see data link layer. The data link layer consists mainly two parts, LLC and MAC. What is LLC? LLC is logical link control. MAC is medium access control. So, what are the responsibilities? Responsibilities are remove bit errors, and next establish visual communication, next frame construction, next error detection comma correction, next flow control and error control. So we want to identify what are the each and every responsibilities. We will see now. Just have a copy this. Mainly the responsibilities of data link layer. Yeah. Well, friends, now here the left hand side, if you consider, it's a last part of your physical layer delays. As I said, to calculate the link efficiency when delays are ignored, you can directly use this equation. If examiner says that you have to use the delays, then write useful time divided by total time consists of all your delays, including these two. Then afterwards, we discussed about data link layer, LLC, logical link control, and MAC, medium access control. MAC we will see later on lectures, but responsibilities of data link layer is removal of transmission errors, virtual communication, frame construction, error detection correction, flow control, and error control. What are the meanings? We will see now. Just to keep heading, first responsibility, removal of raw transmission errors. Write down. Write a point. Write down. Removal of raw transmission errors. Point number 1. LLC by default eliminate transmission errors which are occurred during data transmission. Which are occurred during data transmission. Yeah, this is the first responsibility. Second responsibility, involved in virtual communication. Write a point. All upper layers from application layer to data link layer, all upper layers from application layer to data link layer are involved in logical communication or virtual communication. Are involved in logical communication or virtual communication. Next, responsibility 3, that is frame construction. Write a point. The PDU of data link layer is DPDU is in the form of frames. DPDU is in the form of frames. Next point. Every frame is identified by unique sequence number. Every frame is identified by unique sequence number. Next point. Every frame is identified by header and trailer. Every frame is identified by header and trailer. Header of the frame consists control info. Header of the frame consists control info. and the trailer of the frame consists error detection codes. Trailer of the frame consists error detection codes. Next point. There are two kinds of frames. Fixed length and variable length. Now once see, this is your frame format. Your frame first part is header, last part is a trailer, middle part is a payload. Okay friends? Now you observe carefully, every frame is associated with a unique sequence number, and the sequence numbers can be reused later on once the previous ones are consumed. Okay. And I say this header consists control information, and this trailer consists EDC, error detection codes. Error detection codes or error correction codes, both are same. So now I said another point that there are two types of frames. One is a fixed length, the other one variable length. What are the meanings? If I am saying fixed length frames, the size of the frame is fixed, which tells that every frame must have same length of data. This is the point. So what is the advantage of fixed length? Advantage of fixed length is frame construction is easy, and one more advantage is frame boundary is easy, because we know the length of the frame. So how come it is let size of frame equal to 4 bytes or 4 characters? Total characters are 12. Therefore, number of frames I can easily say 12 by 4, that equal to 3 frames. So which means the first frame consists and second frame consists and third frame consists how many characters? 4 characters. Because the length of the frame is fixed. If I am saying, for example, let size of frame equal to 4 bytes, and I say total characters equal to 10, So how many frames you need? How many frames? 10 bytes by 4, that equal to, once again, how many frames? 3 frames. Now you observe carefully. Frame 1 consists how many? 4 characters. Frame 2 consists how many? 4 characters. But frame 3 has how many characters? Tell me. Because your number of characters are how many? Only 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are becomes what? Empty. So these empty characters you supposed to fill with the artificial data, because length of the frame you have to satisfy to 4. Therefore, this is a character 1, character 2, character 3, character 4, 5, 6, 7, 8, 9 and 10. These two are what? Artificial characters. So you have to attach artificial characters if you unable to satisfy the length of the frame. So you need to have artificial data by the concept of what? Padding. So these two characters are going to be dummy data because your length of the frame is equal to 4. I hope so you got understood what is the concept of fixed length frames. So advantage is very fine, that is frame construction is easy and frame boundary is easy, but what is the disadvantage? There may be a chance of what? Padding. That we want to highlight in the next slide. Okay friends, copy this. Yeah. Well friends, we understood the frame construction is very easy as far as fixed length concern, because it's a predetermined that the length of the frame is fixed. So all the characters are being segregated into rest of the frames based on its length. So what is the disadvantage? The disadvantage is, if at all you are unable to satisfy the data with the specified length, then automatically it leads to padding. That means extra data you're supposed to inject into that. So what do we understand? Fixed length is predetermined. And what is the disadvantage I said? The drawback I said is if frame has no sufficient characters to satisfy the length of the frame, there is a need of padding. Okay, so that's why the frame format consists of, please look at the board, header and a trailer. If at all you have data, you keep it. If you don't have data, you're supposed to have one more field. What is that? Padding is a mandatory, because this length is exactly equivalent to your frame length. That's why it's supposed to maintain two fields, padding as well as data in this. So to avoid the padding problem, we're supposed to use the second category, that is what? Variable length framing. So what is the variable length framing? Is length of the frame is not predefined. Next point, frame consists more or less characters. So this is another mechanism. So what is the problem? Advantage is so high. What is the advantage? No padding. But what is the disadvantage? Is a problem. What the disadvantage is? Identification of boundary of the frame. Because we don't know how many number of characters are there in that. That's why drawback is it's not easy to detect the boundary of the frame as similar to the previous, because the previous I know the length of the frame, therefore I will cut it exactly there, therefore I will come to know that is the boundary and the rest is going to be the next frame. But here I cannot say the boundary of the frame very easily, because a frame consists more characters, a frame consists less characters. Therefore sender is responsible to provide boundaries for the frames. Okay, therefore sender uses frame construction mechanisms. Okay, what are the frame construction mechanisms we see, which are there in variable length framing? Okay, friends, you try to understand very clearly what is that. Fixed length is very easy to construct, and receiver no problem whatsoever, he can easily find the boundary of the frame. But only one point is that you're supposed to maintain two fields, data and padding. Why data and why padding? In the sense, if you frame unable to have the length of the characters, then immediately you're supposed to inject artificial data, nothing but padding of the extra data. To avoid that problem, we are going to see the concept of variable length. There is no concept of any padding, because here we are going to see only that data A frame may consist of more number of characters or less number of characters because length of the frame is not defined here. Advantage is no padding. But what is the problem? The main problem is that the receiver unable to identify the boundary of the frame. So therefore, sender is supposed to do much more work in order to provide what? Boundary of the frame. That's why sender follows some frame construction mechanisms in order to provide the boundary of the frames. So therefore, receiver can easily cut and do the problems. Okay friends, so what are the different kinds of frame mechanisms are there in order to identify the boundary of the frames by the receiver sender has to do, we will see after this slide. Okay, copy. Well friends, I hope so you got copied. We'll meet in the next session by solving different framing techniques problems which are there in variable length frames. Thank you. Stay tuned to us.